Using Cloud Spanner to define a key structure for high-write applications. Your host for this session is Richard Spencer. In this video, I'm going to demonstrate how to set up Cloud Spanner for a high-write application. So once you're in the Cloud Spanner console, first thing we need to do is create an instance. So I'm going to go ahead and click Create Instance. Then I have to name my instance. So I'll call my instance Richard-demo-instance, and I'll give the instance ID Richard-demo-instance-what. Now I can choose between a regional or multi-regional configuration. I'm going to stick with regional, and for processing units, I'm going to leave it at 1000. So you can see your compute capacity guidance if you expand the dropdown here, and you can see kind of how you want to configure your Cloud Spanner for a high-write application. So it supports processing units as well as nodes, and one node is 1000 processing units. So essentially, I'm using one node here. Instances with fewer than 1000 processing units will appear as 0 nodes. Each increment of 100 processing units behaves like 1/10 of a node. Right, that makes sense if one node equals 1000. And Cloud Spanner performance is highly dependent on workload, schema design, and dataset characteristics. So if I change my quantity of processing units to 100, then essentially that's 1/10 of a node. I'm going to leave it at 500. I'll go half a node. You want to delete these instances as soon as you're done. You don't want to incur any costs after the fact. So I'm going to go ahead and click Create, and it creates my instance for me of 500 processing units. And again, to make sure that you're getting the most out of your instance, you kind of have to anticipate and know how much traffic you're expecting to get, so that from an instance perspective, you can handle all the writes and all the activity that's going to be happening in Cloud Spanner. So once our instance is ready to go, now let's create a database. So you'll see databases. I'm going to go ahead and click Create Database. I'm going to call this demo-db. Now it's asking, what dialect do you want to use? Do you want to use Google Standard SQL, or do you want to use PostgreSQL? I'm going to use Google Standard. Next, it's asking us to define our schema. So there's two ways that we can create or alter or delete tables. We can use a default database editor, or we can enter SQL statements in DDL syntax. So here, if you do the dropdown, you can see I have Create Table, Create Index, Create View. I can click these and it fills in the syntax for us. So I'm going to create a table. It's going to be called Singers. I'm going to take in the singer ID, first name, last name, some singer info, and a birthday. So I'm going to paste in my code. You can see it's Create Table Singers. Singer ID is the primary key. It can't be null. First name, last name are both strings, singer info is byte max, and birth date is a date field. So once we're happy here, you can come over. You can also see some sample DDL statements here for altering your database, creating your tables. There's also schema and data. Damit il. So Spanner relies on three core concepts to maximize efficiency. Primary keys. Like we said here, table interleaving. If you're using a lot of parent-child relationships where the child table's primary key is also a parent table's primary key, and the use of foreign keys. So foreign keys are a more general parent-child solution and address additional use cases. Right. Now, there might be a right combination of these needs for you. You may use primary keys, foreign keys, and table interleaving. You can also see some schema updates here. Shows you how you can make schema updates with no downtime and so on. So let's go ahead. Let's create our table. Once the table is created, it'll bring us into the page. The database is now created for us. The database is demo-db. It's a Google standard, and we have a singers table. So now that we have a table, singers, let's create a table called songs. So go ahead and paste in the code to create my songs table. So I've got to create table songs, have the song ID, which is an integer 64, not null. The name of the song is a string singer ID as an integer, and the year it was released as a date. The primary key is the song ID, so go ahead and submit that. So you can see through our use of primary keys, and now how we're going to implement foreign keys to create an efficient schema. So I'm going to come back down to songs again, and I'm going to come in and I'm going to actually click Write DDL, and I'm going to add a new DDL statement. It's going to be alter table, and the table we're going to alter is songs. I'm going to say add foreign key, and the foreign key is going to be singer ID. And it's going to reference the singer's table and the singer ID field in that table. So I'm going to alter this table. So I go ahead and click Submit. And now, once the schema updates, we should be able to see that representation of that foreign key in the songs table. And that gives us our link between singers and songs. So if we come down, we click the songs table. Now, under singer ID, you can see that this column is used by one or more foreign keys. And this links back to the singer ID field in our singer table. The one last thing we can look at is how to use table interleaving. So we looked at foreign keys and primary keys. There's also interleaving, right? So we can create table interleaves. So let's say we want to create one more table. We wanted to create the table albums. So albums is going to have a singer ID, an album ID, an album sans, and an album title. So I'm going to come up and click Write DDL. So I'll paste in my code. It says Create Table Albums. Singer ID is not null. Album ID is not null, taken in the album title. My primary key is singer ID and album ID. And now you see interleave and parent singers, and then on delete cascade. So we're interleaving this into the parent table singers. So what does this mean? Well, Cloud Spanner, based upon this specification and the value of the primary keys, know which children rows belong to which parent rows. This now directs the storage management subsystem to co-locate the child rows of a parent row into the same split, and then therefore into the same storage location. So parent row and its children row are stored in the same location without any distribution, and that really helps when you have a high write application, and there's even a lot of high reads as well. It's good for performance. So go ahead and click Create. It creates the table. You'll see it update the schema. You'll see it under List of Tables. Now, under Albums, you see it's interleaved in Singers. So I hope this video showed you how to design a schema in Cloud Spanner using foreign keys and primary keys and interleave tables. Using Cloud SQL to define a key structure. In this video, you will use Cloud SQL to define a key structure for high write applications. Use Cloud SQL to define get key structure for high write applications. Using Cloud SQL to define a key structure. Your host for this session is Richard Spencer. In this video, I'm going to demonstrate Cloud SQL and look at how to define your SQL database to support high-volume read and write applications. So the first thing we need to do is create our instance. So let's go ahead and click Create Instance. It's asking us for a database engine, MySQL, PostgreSQL, or SQL Server. I'm going to choose MySQL. From here, it asks me for my instance information. It took R Spencer is the instance ID. I'm going to call this Richard-instance-1. I'm going to make sure I have my correct password. I come down, MySQL 8.0 is the database version. I'm going to use US-East 1, South Carolina. I can look at some configuration options here to make it a little cheaper. We don't need 4 cores and 26 gigabytes of memory right now. We can go with 1 core, 3.75 gigabytes of memory. But if you do have a high write application, you're going to want to make sure that you have the appropriate machine type. So you can have high memory, standard, or lightweight. Always check your disk throughput. Under Summary, the details include region, DB version, vCPUs, memory, storage, network throughput, disk throughput, IOPS, connections, backup, availability, point-in-time recovery, right? Right now, it's 48 of 72, and my IOPS is 3,000 of 4,500. If I change this up, you can see how the limits get much bigger. IOPS really increases, and your disk throughput increases as well. So it's just one thing to take into note. I'm going to go with 1 core. I'm going to leave everything else the same and click Create Instance. And once it creates our instance, we can log in and look best practices and how to define a proper Cloud SQL database for a high-traffic application. So now the instance is created. If we come over to Connections, we can see that it is a public IP connection. So come back to Overview, and we should be able to connect to this instance. You can see the public IP address and the connection name. Public IP address reads 35.196.117.30, and the connection name reads CLGPC-US-East 1, Richard-instance-1. So I'm going to go ahead it says to connect using gcloud, click Open Cloud Shell. So I'm going to open the Cloud Shell. It pops up on the bottom. Let's go ahead and expand it here, and we get a bit bigger look at our shell. So once it provisions, now we can interact with our Cloud SQL using Cloud Shell, and it fills in your connection string, Cloud SQL connect dot. It gives me my instance and my user. It's asking me to authorize. So I authorize, and I authorize using my account. So I go ahead and hit enter, and it's allowing my IP, putting on a whitelist for connections, and it's beginning the login process into Cloud SQL. So we'll give it a couple of minutes for the connection to be established, and then we should be able to create a database and look at how we should design our schema in our database to make sure that we can handle a high-write application. So it allowed listed my IP. Now it's asking for my password. So I put my password in, and I'm connected, and I have a MySQL prompt, and that's fantastic. So I'm going to create a database, going to be called guestbook. So I just type in create database guestbook. Now I want to insert some data into the guestbook. So I'm going to paste in my code, use guestbook, create table entries, guest name, content, entry ID. I go ahead and hit enter. Now if we do a select RS from entries, you'll see I get a first guest and a second guest under guest name, and under content was I got here, and boom, me too. So you can paste that data in that comes with this video. It is called samplecode.txt. And now you can see how we actually created our schema and inserted our data. So that's just a simple way to create a table with a primary key. And primary key is efficient because Cloud SQL uses role-based replication. So I'm going to come back out of my Cloud Shell now, and let's take a look at database. So we come over to our database. We'll see the default databases. We'll also see the one that we created called guestbook. So if we come over, we can see some actions like delete. All right, I want to come back to overview. And there's a couple of things I want to talk about under the configuration that you should take into account for high-write applications. One of these is going to be machine type. I know we discussed it previously. We want to discuss it again. We want to make sure that we have a machine type that can handle the amount of read and writes that we're going to put through it. Storage is also important. So you need to make sure that you enable automatic storage increases. So if you near your capacity, storage will be incrementally and permanently increased. And in high-write applications, you're going to get times where your storage is going to need to scale up. And that's what makes Cloud SQL a good option for a high-write application that can use a relational database. Backups are also very important, but for a high-write application, you're going to want to have automated backups through some form of a backup window. Right, you don't want any backups slowing down the performance of your database. Same thing with maintenance. So if you come under maintenance, you're going to want to define a stacking window as well, because if it's a high-write database, it's in use quite a bit. You want to be able to define a maintenance window that you can use to not disrupt your database while you're actually performing some maintenance on it. So I hope this video showed you how to create a Cloud SQL instance, how to create the database, a table with a foreign key, and I hope you understood some of the best practices regarding maintenance windows and scaling for Cloud SQL in a high-write application environment.